Good afternoon, all. Pratibha College of Commerce and Computer Studies, Chinswad, Pune, organizes a certificate course in Basics of Statistics. This course is structured by Department of Statistics. This course consists of 5 modules. The objective of this course is to familiarize the beneficiaries with the concepts of basics of statistics and the methods to measure them in manually as well as in statistical software like R. Research students, industrialists, and government employees will get benefit from this course. After completing this course, the beneficiaries will be able to understand and calculate the measures of central tendency. They will be able to understand and calculate the measures of dispersion, understand and calculate the correlation between two variables. They will be able to fit the simple linear regression line, and they will be able to understand the procedure of descriptive statistics, correlation, and regression in R software. This course contains 5 modules, of which I, Pournima Ajagekar, presents Module 2, Measures of Dispersion. Under this module, I am going to cover these points: introduction, characteristics of good measure of dispersion, types of measures of dispersion, absolute measures of dispersion, range, quartile deviation, mean deviation, standard deviation, and relative measures of dispersion, coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, and coefficient of variation. If we have the raw data or unprocessed data, then there are various methods to summarize that data. One of the method is to represent the data graphically. However, it becomes essential to condense the data into a single value. Such a single value represents the entire data, and that single value is called as average or central value or measure of central tendency. Measure of central tendency helps to sum up the data into single representative value. However, that value does not reveal the variability present in the data. For example, consider this data. Suppose the 3 friends, Ram, Kiran, and Pooja, are uh, chatting over tea, and they are discussing about their family incomes. There are 4 members in Ram's family, and the average income per member is 15,000. There are 6 members in Kiran's family, and the average income per member is similar, that is 15,000. And in Pooja's family, there are 5 members, from which one of the member is earning zero, and one of the member is earning maximum income, that is 50,000, and still the average income is 15,000. Average income per member in Pooja's family is 15,000. Although the average is same, there are considerable differences in everyone's income. So averages try to tell only one aspect of a distribution, that is representative size of the values. To understand it better, we need to know the spread of the values also. Knowledge of only average is insufficient. If we have another value which reflects the quantum of variation in values, our understanding of a distribution improves considerably. For further study and analysis, it becomes essential to measure the extent of variation. Observations are scattered or dispersed from central value. This variation is called as dispersion. So basically, what is mean by dispersion? Dispersion is the spreadness or scatteredness in the values of observations from the central value. To study this dispersion or variation in data, it is required to define certain measures of dispersion. There are different types of measures of dispersions are defined. To measure the measure of dispersion indicates the scattering of data. It explains the disparity of data from one another. The measure of dispersion displays and gives us an idea about the variation and central value of an individual item. In other words, dispersion is the extent to which values in a distribution differ from the average of the distribution. It gives us an idea about the extent to which individual items vary from one another and from the central value. Now there are different types of measures of dispersions are available. So which one is good amongst them, that will be studied by considering some characteristics of the measures of dispersion. So here we will see the characteristics of a good measure of dispersion. It should be easy to calculate and simple to understand. It should be based on all the observations of the series. It should be rigidly defined. It should not be affected by extreme values. It should not be unduly affected by sampling fluctuations. It should be capable of further mathematical treatment and statistical analysis. Now there are different types of measures of dispersions. Absolute measures. Absolute measures of dispersion are expressed in the unit of variable itself, like kilogram, rupees, centimeters, marks, etc. For example, if we have the data of uh, uh, weight of a person in kg, then whatever measure of central tendency we will compute, that will have the unit kilogram. The second one is relative measures of dispersion. Relative measures of dispersion are obtained as ratios or percentage of the average. These are also known as coefficient of dispersion. These are pure numbers or percentages totally independent of the units of measurements. To quantify the extent of the variation, there are certain measures. Uh, Range, quartile deviation, mean deviation, standard deviation, these are absolute measures of dispersion. And coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, and coefficient of uh, variation are the relative measures of dispersion. So we will see one by one each of the measure of dispersion. So first one is range. It is the simplest method of measurement of dispersion and defines the difference between the largest and the smallest item in a given distribution. So range is equal to L minus S, where L is the largest item in the distribution and S is the smallest item in the distribution. Higher value of range implies higher dispersion, and the smaller value of range implies there is smaller dispersion in the data. The corresponding relative measure is coefficient of range, which is defined as L minus S divided by L plus S. Now we will see how to calculate this range for different types of data. Firstly, we will calculate the range for ungrouped data. So consider the example. Compute range and coefficient of range for the daily wages of 8 workers in a factory. So we have given the daily wages of 8 workers. And for this data, we have to compute the range. Okay, from the data, we can observe the largest observation L as 150 and the smallest observation S is 75. So the range is L minus S, that is equal to 150 minus 75, which is equal to 75. And the corresponding relative measure, coefficient of range, is equal to L minus S divided by L plus S, and that we get 0.3333. Now we will calculate the range for grouped data. Find the range and coefficient of range for the following frequency distribution. So here we have the data, grouped data, that is in the form of class intervals and frequencies. Now in this case, range is just the difference between the upper limit of the highest class and the lower limit of the lowest class. So here the highest class is 25 to 30. So upper limit is 30 and the lowest class is 5 to 10 and its lower limit is 5. So range is 30 minus 5, that is equal to 25. And the coefficient of range is L minus S divided by L plus S, which is equal to 0.7143. Now we will see the merits and demerits of the range. Merits are: it is very easy to calculate and simple to understand. No special knowledge is needed while calculating range. It takes the least time for computation. It provides a broad picture of the data at a glance. And the demerits are: it is a crude measure because it is only based on two extreme values, that is highest value and lowest value. It cannot be calculated in the case of open-end classes. Range is significantly affected by fluctuations of sampling, that is, it varies widely from sample to sample. The range can be misleading because it ignores the way in which the observations are distributed. The second measure of dispersion is quartile deviation. The upper and lower quartiles, that is Q3 and Q1, are used to calculate the interquartile range, which is Q3 minus Q1. Interquartile range is based upon middle 50% of the values in a distribution and is therefore not affected by extreme values. Half of the interquartile range is called as quartile deviation. Thus, quartile deviation is equal to Q3 minus Q1 divided by 2. Quartile deviation is therefore also called as semi-interquartile range. The corresponding relative measure is coefficient of quartile deviation, which is equal to Q3 minus Q1 divided by Q3 plus Q1. Now we will see how to calculate this quartile deviation for different types of data. Firstly, we will compute quartile deviation for ungrouped data, that is raw data. So consider the example. Calculate quartile deviation and coefficient of quartile deviation of the following observations. Okay. So here, firstly, we need to compute the first quartile Q1 and the third quartile Q3. For that, we need to arrange this data in ascending order, and as we can see, the data is already arranged in ascending order. Okay, so here the total number of observations are 11. Now Q1, that is first quartile, will be the value of the n plus 1 by fourth observation. So here the number of observations are 11. So Q1 will be the value of the 11 plus 1 by fourth observation, that is 12 by 4, that is third observation. Q1 will be the value of third observation, which is 29. Similarly, Q3 is value of the 3 by 4 into n plus 1 by fourth observation. So if we substitute the value of n, that is 11, we get Q3 is the value of the ninth observation, which is equal to 51. And then quartile deviation is Q3 minus Q1 divided by 2, which is equal to 51 minus 29 by 2, that is equal to 11. And then the coefficient of quartile deviation is Q3 minus Q1 divided by Q3 plus Q1, that is equal to 51 minus 29 divided by 51 plus 29. So we get that 0.375. Now we will compute the quartile deviation for grouped data. For the following distribution of marks scored by a class of 40 students, calculate the quartile deviation and coefficient of quartile deviation. So here we have the data in the form of class intervals and frequencies. And for this data, we have to calculate the quartile deviation. Firstly, we need to compute the first quartile and third quartile. Now, in this case, to obtain the first quartile and third quartile, we have to first calculate the less than type cumulative frequency, LCF. So to compute these LCFs, we have to add the frequencies from top to bottom. So here we get the column of LCFs. Now, to find Q1, firstly we have to calculate the value of n by 4. So total frequency is 40. So 40 by 4 is 10. And then from the column of LCF, find the LCF just greater than 10, which is 13. In the column of LCF, you can see the LCF just greater than 10 is 13. And the corresponding class is 10 to 20. So in this class, the first quartile will lie. The first quartile will belong to this class 10 to 20. Okay, now for that class, the lower limit L is 10, the cumulative frequency of previous class is 5, the frequency of that class is 8, and the class width of that class is 10. So we have the formula for Q1 is L plus N by 4 minus CF divided by F into H. So lower limit is 10, 10 plus N by 4 is 10 minus cumulative frequency of previous class is 5 divided by frequency of the class is 8 and into class width is 10. So when we substitute all the values in the formula, we get first quartile equal to 16.25. Then to compute third quartile, firstly compute 3 into n by 4, so which is equal to 3 into 40 by 4, that is equal to 30. And then in the column of LCF, we have to find the LCF just greater than 30, which is equal to 36. So here in the column of LCF, the LCF just greater than 30 is 36 and the corresponding class is 40 to 60. So the third quartile Q3 will belong to this class 40 to 60. So for this class, the lower class limit L is 40. The cumulative frequency of previous class is 29. The frequency of that class is 7 and class width is 20. So formula for third quartile Q3 is L is equal to 3n by 4 minus Cf divided by F into H. So substitute all the values and then we get Q3 equal to 42.8571. And then quartile deviation is Q3 minus Q1 by 2, that is equal to 42.8571 minus 16.5 by 2, which is equal to 26.6071. And the quartile deviation is Q3 minus Q1 divided by Q3 plus Q1, which is equal to 0.4502. Now let's see what are the merits and demerits of the quartile deviation. Merits are it can be easily calculated and simply understood as it takes middle 50% observations, hence it is a measure better than range. It is not affected by extreme observations. In case we are to deal with the center half of a series, this is the best measure to use. And demerits are as Q1 and Q3 are both positional measures, hence are not capable of further algebraic treatment. Calculations are much more, but the result obtained is not of much importance. It is too much affected by fluctuations in sample. The third measure of dispersion is mean deviation. It is also called as average deviation. It is defined as the arithmetic average of the absolute deviations of observations of the series computed from measure of central tendency like mean or median. Okay, so depending on uh, from which measure of central tendency we are taking the deviations of the observations, different formulae for this mean. Suppose if we are taking deviations of observations from mean, then we can define the mean deviation from mean. So here we have the formula for mean deviation from mean. X bar is equal to 1 upon n summation of mod of xi minus x bar. If we take the deviations of observations from median, then we compute the mean deviation about median, that is equal to 1 upon n summation of xi mod of xi minus median. And the corresponding relative measures are coefficient of mean deviation about mean, coefficient of mean deviation about median. So The coefficient of mean deviation about mean is mean deviation about mean divided by mean, and coefficient of mean deviation about median is mean deviation about median divided by median. Now we will compute this mean deviation for some examples. The marks of 10 students are given as 45, 60, 65, 78, 91 and so on. Compute the mean deviation about mean x bar and coefficient of mean deviation about x bar. So firstly here we have to calculate the mean of given data. The formula for mean is summation xi divided by n. The sum of all these observations is 592 and there are total number of 10 observations. So when we substitute this sum and the total number of observations in the formula, we get mean x bar equal to 59.2. Then we have to take the deviations of these observations from mean. That means we have to take these deviations, 45 minus 59.2, 60 minus 59.2, 65 minus 59.2 and so on. And then we have to consider the absolute deviations, and the sum of these absolute deviations is 173.6. Then the formula for mean deviation about mean is 1 upon n summation of mod of xi minus x bar, and we get the sum of absolute deviations is 173.6 divided by 10, that is equal to 17.36. So mean deviation about mean is 17.36. Then coefficient of mean deviation is equal to mean deviation about mean divided by mean. So that is equal to 17.36 divided by 59.2, which is equal to 0.2932. Okay, so in this way we can calculate the mean deviation about mean for ungrouped data or for raw data. So here you can see the table of calculations. Firstly, we have to compute the mean, and then after that we have to take the deviations of observations from mean, and then we have to consider the absolute deviations. Now we will calculate the mean deviation for grouped data. Calculate the mean deviation x bar and coefficient of mean deviation x bar for the following frequency distribution. Now here we have given the discrete frequency distribution, observations with their frequencies. In this case, the formula for mean is summation Fixi divided by total frequency. Here we have the table of calculations. Firstly, we have to prepare the columns like Fi into Xi. This column will be we have to prepare this column to get the summation Fixi. From this sum, we can calculate the mean. Here x bar equal to summation Fixi divided by total frequency, and we get mean x bar equal to 34.98. Then we have to take the absolute deviations of observations from this mean value. So here is the column for that, for those absolute deviations, and then we have to make this column frequency into these absolute deviations, and then we have to find the summation of Fi into mod of Xi minus X bar, and that sum is 247.22. Then the mean deviation from mean will be 1 upon capital N summation of Fi into mod of Xi minus X bar, and we get that mean deviation 5.0453. Then coefficient of mean deviation is mean deviation about mean divided by mean, and we get that coefficient equal to 0.1442. Let's see what are the merits and demerits of this mean deviation. Merits are: it is simple to understand and easy to calculate. It is based on each and every item of the data. Mean deviation is less affected by the values of extreme items than the standard deviation. The greatest drawback of this method is that Algebraic signs are ignored while taking the deviations of the items. These are the demerits of mean deviation. It is not capable of further algebraic treatment. It is much less popular as compared to standard deviation. Now we will see the fourth measure of dispersion, which is standard deviation. The most important and widely used measure of dispersion. This is the most important and widely used measure of dispersion. It is first used by Karl Pearson in 1893. It is also called as root mean square deviation. It is defined as the square root of the arithmetic mean of the squares of the deviations of the values taken from the mean. So to compute this standard deviation, firstly we have to take the deviations of observations from mean, then we have to consider squares of those deviations, then we have to find the arithmetic mean of those squares, and finally we have to compute the square root of that arithmetic mean. In this way we can compute the standard deviation for any data. It is denoted by sigma. Once again, we will see the definition. Standard deviation. Standard deviation is the square root of the arithmetic mean of the squares of deviations measured from the mean. The standard deviation is denoted by sigma, and it is given by, for individual observations or for raw data, the formula of standard deviation is square root of 1 upon n summation of xi minus x bar square. And if we have the frequency distribution, discrete frequency distribution or continuous frequency distribution, in that case the formula for standard deviation is square root of 1 upon capital N summation of fi into xi minus x bar square. After simplification, we can have computational formula for standard deviation in more suitable form as follows. So after simplifying the above formula, we get the standard deviation for individual observations is square root of 1 upon n summation of xi square minus x bar square, and for frequency distribution sigma is equal to square root of 1 upon capital N summation of fi xi square minus x bar square. We will define some terms here. Variance. The quantity sigma square is called as variance, that is, square of the standard deviation is called as variance. The corresponding relative measure is coefficient of variation. Professor Karl Pearson suggested the relative measure of standard deviation, and it is called as coefficient of variation, and it is defined as CV equal to standard deviation divided by absolute value of mean, arithmetic mean, into 100. So that is nothing but sigma divided by absolute value of mean into 100. Okay, if we have given two different data sets, then the data which is having smaller coefficient of variation is said to be more consistent data. In order to check the consistency of data, we have to calculate the coefficient of variation. If the value of coefficient of variation is smaller, then that data is consistent, or if the value of the coefficient of variation is higher, then that data is less consistent. Okay, so to compare the two different data sets, that means which data is more consistent, we have to compute this coefficient of variation. Calculations of standard deviation for ungrouped data. Compute the standard deviation, variance, and coefficient of variation for the following data. We have given some data which is raw data. So firstly we have to compute the mean x bar equal to summation xi divided by n, that is the summation xi is 90 divided by number of observations are 5. So we get mean x bar equal to 18. Then standard deviation. Okay, so to compute the standard deviation, this is the formula: 1 upon square root of 1 upon n summation of xi square minus x bar square. So we have to prepare the column of squares of observations. Here you can see the table. Here we have computed the squares of all the observations. Then we have to take the sum of these squares. Then substitute the respective sums in the formula, and then we get standard deviation equal to 5.2536. And then variance is nothing but square of the standard deviation. So square of 5.2536. So variance is equal to 27.6, and then coefficient of variation is sigma divided by mod of mean into 100, and then we get coefficient of variation equal to 29.1867%. The coefficient of variation is expressed in percentage. And calculation of standard deviation for grouped data. Calculate variance, standard deviation, and coefficient of variation for the following frequency distribution. So here we have given the continuous frequency distribution, class intervals, and frequencies. In this case, we consider the xi's as midpoints of the class intervals. So firstly, we have to compute midpoint of each interval. So these are the midpoints of each intervals, 4, 5, 6, 7, 8. Then we have to add the two columns, the column of f into x and the column of f into x square. From these columns, we will get the sums summation fixi and summation fixi square. And from the column of frequencies, we get the total frequency. So the mean x bar equal to 1 upon capital N summation of fixi, which is equal to 6.1781. And the variance sigma square is equal to 1 upon capital N summation fixi square minus x bar square, and the variance is equal to 1.7352. And then standard deviation will be, as variance is the square of standard deviation will be square root of the variance. So we get standard deviation square root of variance, that is equal to 1.3173. And then coefficient of variation is CV is equal to standard deviation divided by mod of mean into 100, and we get coefficient of variation equal to 21.3189%. Merits and demerits of standard deviation. Merits are, it is rigidly defined, it is based on all the observations of the series, and hence it is representative. It is amenable to further algebraic treatment. It is least affected by fluctuations of sampling. And demerits are, it is more affected by extreme observations. It cannot be exactly calculated for a distribution with open-end classes. It is relatively difficult to calculate and understand. So these were the points that I wanted to cover under the module measures of dispersion. After this course, I have prepared one quiz, and this is the link for quiz. I have completed my presentation. Thank you all.